All right, welcome. This is our 2-3 segment and angle proofs. So our last notes, we're looking at algebraic proofs. So we just looked at basically solving algebraic problems and giving our good reasons why we do them. And today we're going to extend that. So these were kind of the properties we looked at the other day. Properties of equality were addition, subtraction, multiplication, division, distributive property, substitution, reflexive, symmetric, transitive property. All these things we could do within algebra. We can do some of these also with shapes, and we're going to be doing that with segments and angles today. But when we say equality, we're usually talking about measurements, right, or equal sign. But we're going to look at properties of congruence, which, again, we know the word congruence usually is applied to our notion of talking about a shape being the same size and shape. Just like in transformations, we'd map one transformation over another. That's the definition of congruence. So these three look very similar. Instead of equal, we're going to have congruence, and this is because we're talking about shapes. And for today, we're going to be looking right now at segments in specific. Okay, so for any segment AB, we should have a little line over that, is congruent to AB. So I'm basically saying a segment is congruent to itself, right? I could overlap itself and it would be the same. Symmetric property would be segment AB is congruent to segment BC. If that was true, then I could just flip those around and that would also be true. And then transitive is very similar, right? If AB is congruent to CD and CD is congruent to EF, then my assumption is, because CD is transmitting the information that we can then connect these two, as AB is congruent to EF. Okay? And again, the big key is we're talking about congruence here, so we've used the congruent symbol, meaning same shape, same size, for these items. In this case, we're talking about segments. All right, so let's talk about the definition of congruence. Segments are congruent if and only if they have the same measure. So we can actually go back and forth between these. So I can say AB is congruent to CD as long as the measure of AB is equal to the measure of CD, and I can do this back and forth. Right, so the measure of AB is equal to the measure of CD, like this could be 10 feet long, 10 feet long. Then if that's true, then I know that the segment is congruent to this, because mainly the only piece of the segment is its length. Definition of midpoint. So we do use midpoint as a part of our definition. The midpoint of a segment divides the segment into two equal parts or congruent parts. So if M is the midpoint of AB, then AM would be equal to MB. And we have the segment addition postulate, which again, this should be kind of like old news, but we can use this as a reason why we can create and set up a proof, and that is AB plus BC equals AC. So again, these are some things that we can use to help us do some proofs. So let's get some proof practice. So now there's 3 proofs. I'm going to do 2. At any point, if you want to try it yourself, go ahead and pause it. But this is how I approach my proofs. So when I do a proof is I first like to just kind of cover up the statement and reasons that are already there, and I like to just think about what I'm given. All right, so first of all, it says E is the midpoint of DF. So E is the midpoint of DF. So I like to mark my picture. Automatically, I know that these two segments are congruent. Cool. Then it says 2DE is equal to DF. Okay, so DF right here is the whole thing, and 2DE is this and that twice. Well, I know that DE and EF would make DF. That would be segment addition postulate. And I know that DE is equal to EF, so I could see how this would make sense. I'm just kind of writing it like this. So I'm going to now attack the problem that I thought about it, And let's go through all of my statements. So it says E is the midpoint of DF. Well, usually whatever the statement is that we start with is given. Notice that we're going to end with our proof. We don't write the word prove. That makes no sense. That's not a reason. You never argue with someone. Ice cream is the best. Prove. It doesn't make any sense. So E is midpoint DF. That was given to me. That was a piece of information given. DE equals EF. Well, how do I know DE equals EF? Well, that keyword midpoint. And again, you kind of want to sometimes look at what we've already done to dictate what's going to come next. And that's why we want a logical flow of information. So this is going to be definition of midpoint. Midpoint means I'm going to have two equal parts. All right, now this is where it gets interesting. What happened from step 2 to step 3? Well, they're pretty much the same except for I threw a DE on both sides. Okay, so I added a DE to both sides. Since I'm doing it to both sides, this would be addition property of equality. So we have to really look at what we're doing. All right, next we get 2DE, DE plus EF. So what happened here? Well, I really just kind of combined the 2 DEs into 2 DE. So this is just combining like terms. And then, let's see, down here. Now, here, I don't know how I went from here to here, and sometimes it's not necessarily true that I'm going from here to here, but this kind of just looks like DE plus EF equals DF. That looks like my segment addition postulate. And then last but not least, okay, last but not least, we see that we get this guy, our final answer. Okay, so this is where we have to be a little tricky, and I'm going to see if I can help you out. So we want to look above. Now, I don't know how I go from here to here, but I see that this piece is in common with this piece right here, okay? And we have this piece, 2DE, is the same as this one right here. And we have DF is the same as this one right here. So if we look at that, I'm saying green equals blue, blue equals yellow. What would have to be true? Well, if green is the same as blue and blue is the same as yellow, then I think we could assume that green is equal to yellow. So this is actually our transitive property that is allowing us to make this connection. Again, you have to have a great knowledge and understanding of your vocabulary. Also, we want a logical flow of information. Now, we kind of discussed how, I know this and this equals this, and I know this is equal to this, so we did have to tie it together, and sometimes transitive property is that tie together. All right, we're going to do one more. And I'm going to actually skip the middle one. I'm going to let you try that one. I'm going to do 3. We'll come check out number 2 on in class. So let's take a look at this one. Again, I don't really like to look at the bottom part. So I'm going to just look here. It says E is the midpoint of AC. So I'm going to just mark right now E is the midpoint of AC. And then it says DE. Okay, DE is equal to EC. So to do that, that's a little tricky. I'm going to go ahead and put 2 marks here, but then 2 marks here. So I kind of know that EC is equal to AE and EC is equal to DE. Now I'm going to try and show DE is equal to AE. That's sounding like transitive property, right? I'm saying EC is going to be the same as AE. EC is the same as DE, so thus those two have to be the same. For example, if AE is 10, that means EC would be 10, and if EC was 10, that means DE would have to be 10. So this is probably going to be transitive property is what my assumption is going to be. All right, let's go ahead and jump into it. Now this one's a little different because I have some blank statements, but then I have some reasons. All right, E is the midpoint of AC. All right, well, that's given to me up here, so that's given. Definition of midpoint. So the first thing I want to do is I want to enact what's true from this. And from this I have AE is equal to EC. All right, cool. Next is a given. Well, I look up, I have another given. That's a DE is equal to EC. Okay, so that's my other given. And then it says AE equals DE. AE equals DE. Again, you can kind of see this transitive property occurring. I have my green here. I have my yellow here. And notice right above it I have blue and blue. So I'm saying green equals blue, yellow equals blue. Well, if they both equal blue, that means they should equal each other. There's my transitive property. Okay, now it says definition of congruence. That means I'm converting AE equals DE into AE is congruent to DE. And then this last bit is a little bit of fun. It wants DE first and AE second. So how do I go from here to here? Well, I'm just going to flip those two. So I'm going to use my symmetric property to do so. All right, cool. Moving on. Angle proofs, yes. Okay, so angle proofs, we have a lot of definitions in here. So again, we still have all of our properties of equality and properties of congruence from before. We do not want to forget those for our angle proofs. We have a bunch of other stuff here. So here's my definition of congruence. It works for the measure of an angle is equal, then the angle itself is congruent. We've talked about angle bisectors before. So an angle bisector divides an angle into equal parts. Complementary at 90, supplementary 180, definition perpendicular, create right angles. Definition of right angle creates a 90. So again, we're just kind of throwing a lot of this vocab that we've already talked about. Angle addition postulate, right? This plus this equals the bigger angle. And then we get to some theorems. These things are already proved, but we don't necessarily have to prove them anymore, so we can just use the piece of resistance that we already have it. So vertical angles theorem, if two angles are vertical, then they're congruent. Complement, if two angles form a right angle, then they're complementary, right? Same thing, supplement theorem, if two angles form a linear pair, they are a linear pair and are supplementary. Congruent complements theorem, this one's kind of new, and congruent supplements theorem, but basically if A is complementary to B and C is complementary to B, then they're equal to each other. I'm just going to quickly draw a little picture of what that would look like. Okay, so boom, 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 boom. It's going to work the same thing for the next one as well. So let's just say we had B and C here. Those add to 90. A is complementary to B. That's what I meant to do. And C is complementary to B, then A and C are congruent. And this is easily proved. Let's just say B is 40 degrees in this situation. Well, if B is 40 degrees, then these two add to 90. That would have to be 50, and this would have to be 50, which proves that A and C would have to be congruent. Okay, so this is kind of like a little visual proof of that. It works the same thing for supplement as well. The only thing I want to add up here to our definitions that we don't have is we can do a definition of linear pair, which again, basically they equal 180 and they form on a straight line. So that's a plus sign, sorry, equals 180. So we do have linear pair that we can use as well. All right, I'm going to do 2, you're going to do 1, and we'll call it all fun. So here we go. Complete the proof by filling in the missing term. And again, I want to think about it real quick. So it's a right angle. So this is a right angle, so I'm going to put that in. And I want to show that PQS and SQR are complementary. So I'm actually doing a proof of one of the theorems we already have. So we can't use that theorem, right? So I'm actually proving the complementary theorem. So let's get into it. So PQR is a right angle. All right, well, that would be just given. It told me that in the beginning. So that makes that, pretty easy. Next it says PQR equals 90. All right, well, that's just the definition of a right angle, right? You're physically saying right angle is now 90 degrees. And then you're saying PQS and SQR equal PQR. So this is just our angle addition property. Right? And then we get this equals 90. Well, we can do this in two different ways, but it looks like I'm just saying, hey, look at right here, PQR equals 90. This is PQR, so we can substitute that 90 out and make it really, really easy on us to get our substitution property. And then if those two angles add to 90, that would be our definition of complementary angles. And there you go. So this one doesn't look like transitive property as much because I'm not showing like this equal, this would be green, blue, this would be yellow, green. So this is more of what we call just a straight up substitution, because all I did is I kept this the same and I just switched this out for 90 because we already knew it was 90. So that's just a straight substitution, not a transitive property on that one. All right, next I'm going to go ahead and skip 2. You can do 2. Let's do number 3. I'm just going to go ahead and look at this guy. We have angle 1 is equal to 4, so I'm actually going to mark angle 1 and 4 are congruent. 4 and 5 form a linear pair, so I know those are going to add up to 180. And we want to show 1 and 5 are supplementary. Well, if 1 and 4 are congruent, let's just call 4 100 degrees. That would be 80 degrees. Those would also have to be supplementary. So I think we can get this. Let's go. Angle 1 is congruent to angle 4. That's given to us. Definition of congruence. Whenever you see that, basically just switch it from congruent to equal. And for angles, a lot of times we'll put the word M or letter M in front of it, which means measurement. Then it asks for another given, and that's just that 4 and 5 form a linear pair. Oops, squeeze that in there. And then it says 4 and 5 are supplementary. Well, that's the definition of linear, right? And then let's actually say that they add to 180 because we need to eventually get down to numbers. And that's the definition of supplementary angles. And then we're going to substitute. So what do I want to substitute? Again, I want to get 1 and 5 are supplementary. Well, so if I take actually 4, I know what 4 is equal to. 4 is equal to angle 1. So I should be able to just plug in angle 1 here instead. So the measure of angle 1 plus the measure of angle 5 equals 180. And that substitution should say property. And then if they add to 180, then that's would mean they're supplementary, which is just using the definition of supplementary. And there you go. All right, this does take practice. This does take time to get used to, and I do think that we can get there. So thank you very much.